So I am going to do exercise 26D, question 1F with you. So that's a sequence that's 2, 7, 18, 38, 70, 182, and so on. Okay. Right. So when we've got a sequence, let's say we're not told what it is, how do I find out whether it's arithmetic in nature or geometric in nature?
You find the difference between all of them and the difference between differences.
So, but how would I know whether to do a difference or whether to do a ratio?
First you find a difference, then you tell. Because then, because then the difference will be the same.
So what do you think with this one, whether it's if you were just given a sequence and you're not told this is linear, this is quadratic, this is geometric, and you're just told to find the general rule for it, you have to make a decision, don't you? Because that difference method that I asked you to look at only works if it's sort of that arithmetic in nature, the adding stuff. If it's geometric, it won't work, will it? So we can look at it and go, right, what do you think? Is it going to be a geometric?
Yes.
No. I think it's quadratic. I think it's cubic.
Well, it's quadratic because we know it from the question in the book, and it says, that's the section we're doing. But let's say you're in an exam, you've got to make a decision. Is this going to be geometric? Well, there's one way to find out, which is we test it and say, well, I've got to do 7 over 2. Does that equal 18 over 7? No. Okay, so it's not geometric. So when we know it's not geometric like that, I'm going to give myself some space again. I'm going to go for looking at the difference and seeing whether I've got a common difference. So I'm going to look at it, it's plus 5, then it's plus 11, then it's plus 32.
47.
40.
And then
Is that right?
Yes.
Okay, so we don't have a common difference, so my first line of difference is not common, so I'm going to go for my second line of difference. So that would be 6, 8,
No. Other than verifying.
18.
okay. So actually, for my second line of difference, that was where it would tell me, well, that would be a quadratic. It's not that. Okay. So we have to go to my third line of difference, which will be.
No, wait, isn't that 9?
Sorry.
That's 4.
No, that should be 9.
So-
that should be
Yeah.
that should be a 9.
That should be a 9.
So then it's
3, 3, 3, 3. Okay. So that makes me think it's got to be a
3.
cubic. So we need to think, well, how do we do that then? So, tell you what, this is something that I'm going to do on a separate page. So we're looking at the difference rule. So we're actually taking a step past the quadratics that we've been working on and showing that we can use this method for anything. Alright? So a quadratic, now what we need to know is a quadratic will be potentially in the form ax cubed plus bx squared plus cx plus d. Okay? Now, what I need to do is I'm going to set up the table that I need to use. So, do you remember what we said? If I've used x's again, but because I'm going to do a sequence, I'm going to change my x's. I know it's easier for me to do than you, but so feel free not. I'm going to call it n instead of x. Alright, just because we're doing sequences. So if I want to know the first term in the sequence when n is 1, what will this, if I don't know what A, B, C and D, what would it be? So I substitute 1 in for n's and I actually end up with A plus B plus C plus D. Right? Make sense?
Why do you substitute with one?
Because n is 1. The first term in a sequence, the first term of a cubic sequence will be add all the coefficients together. Because you put n as 1 in. Yeah? Does that not make sense? Are you just accepting it or are you understanding it? Well, can we maybe explain? Maybe I'm not doing a good job. Yeah?
He's just saying if you substitute n as 1, you can do it because 1 to the power of
Yeah.
anything is
So I've
still
got
1.
A times 1 cubed plus B times 1 squared plus C times 1 plus D, yeah? That's how I find the first term of the sequence because n equals 1, yeah?
Okay.
And what is A times 1? B times 1, C times 1, and so on, yeah? So the second term of the sequence is when n is 2. So what would that be? Be A times 2 cubed plus B times 2 squared plus C times 2 plus D. So what would it be? So the second term would be 8A plus 4B plus 2C plus D. Alright. Now, by the way, I know what's going to happen here. I need to go down below that, so I'm going to be rubbing this stuff off in a minute. Alright? So don't block your route down. I need to find the differences, don't I? Alright? The third term,
Sorry, I don't understand what you just said.
well, I'm going to be using the difference method. So I'm writing this, but I can rub it out easily. So what I'm saying is you can't necessarily, so maybe you need to write, if you want to write this, then write it somewhere else. So the third term would be A times 3 cubed plus B times 3 squared plus C times 3 plus D. So that would give me
27A plus 9B plus 3C.
okay. And I'm going to do one more, if I can fit it in. The fourth term in the sequence is going to be, yeah, go on.
Wait, no, I have a question.
Yeah,
but
go
I
on.
could figure that out.
No, what's your question?
Right. I was gonna say, yesterday we only had like A, B, and C. Did we add?
That's because it was a quadratic.
Like-
Do you remember
This is
yesterday?
a quadratic.
No, this is a cubic, because remember we went to the, up here, look.
So quadratic only has 2, and it's.
So if we got to the second line of difference, it would only be a quadratic.
Okay.
So we would stop at ABC. But because we've gone to the third line of difference, it's a cubic. So we've got ABCD. If we went to the fourth line of difference, we would have
A,
A, B, C, D, E to deal with. Yeah. So I'm just going to finish this off
And
then,
Do you want me to say the next one?
if you like.
Okay, so it's A times 4 cubed plus A times
B time.
B times 4 squared plus C times 4 and then plus D.
Yeah.
Is it better to line them up that way at the top or downward is fine as well?
What do you mean? These ones.
No, the ones at the
These
top.
ones. No, I want to do it along the top because I'll explain in a sec what I want to do. I'm just going to work this out. So what's 4 cubed?
252.
84?
Is it 84?
Is it 84?
It's 64.
Oh, I don't know how to write it.
64A plus 16B
Times 4C.
plus 4C plus D. Now, can I just rub these out now? Because these were my workings. That's why I said I need to rub these ones out. Let's erase them. Okay. So I've got my space. Now, this is where, I guess, the thing that some people didn't quite get yesterday, which is I now need to compare these, or what I'm going to do is I'm going to compare those to these, right? So these numbers are the first four. So basically what I've got is these numbers here, A, B, C, D, relates to which number in this table? Because that was a general form of doing. This is an actual sequence. So A, B, C, D is which number on here?
2.
It's the 2. It's the sequence. It's the first line of the sequence. Yeah. Let's pick this one. The 27A plus 9B plus 3C plus D relates to which number?
18.
The 18. Okay. All right. So what I'm going to do now, because what I want to do, I know there's a common difference down here at the 3s. So I need to get that far. All right. With my algebraic stuff. So what I'm going to do.
Hey, I'm really confused. How can you relate it back to like find it?
Okay, so we'll hopefully when we've got there, it'll make sense. So this line is the actual numbers of the sequence. But what do we do when we've got a sequence? What's the first thing we need to look at? We look at the differences. We have to find the differences. So this is the sequence. So what I'm going to do now is I'm going to find the first line of difference, but I'm going to do it algebraically as a general thing. Yes?
Will a sequence always be cubic if it has more than 2 lines of differences?
So it's the third line, it's cubic, it's the fourth line, it's power of 4 and so on. So I want to find my first line of difference. So what I'm going to do is I'm going to find the difference between those two to get my first line of difference. So what I'm doing now, just to make it clear, is my first line of difference, right? So what I'm going to find here with my algebra relates to which line here? The first line of difference. So what I'm doing now is I'm finding the algebra for these numbers. Alright? But I'm going to do it in a general form. So I just have to find. So what's the difference between 8A, so I've got to subtract that. So what is it? So 8A subtract A is 7A
Plus 3B.
plus 3B
Plus C.
plus C. The D's go. Alright? Then the difference between the next ones are
19A. 19A.
so 19A
Plus 5B.
plus 5B
Plus C.
Plus C.
plus C. And then the difference between these ones
37A plus 7B plus C.
alright?
How many variables for the first line of difference?
Because I've done it with numbers, I've just done it with the coefficients, the algebra. So I've just done one subtract the other. So basically, if I look at this one here, I'm going to rub this off, by the way, so if you write somewhere else. I've done 8A plus 4B plus 2C plus D, the second term, and I'm subtracting A plus B plus C plus D. So that's like doing subtract A, subtract B, subtract C, subtract D. So I've got 8A, subtract A, 7A. 4B, subtract B, 3B, 2, and so on. Yeah?
So that's the formula for the first term, second term, and third term?
That's the formula. These are the formulas for the terms in the sequence. These are now expressions, formulas for the numbers in the first line of difference.
Okay.
So what am I going to do now? I've got to find the second line of difference.
So do you find the difference?
So I find the difference between those now.
I'm really confused why you're doing
12A plus 2B.
Alright, we'll come to it. So 12a plus
2b.
2b.
18a plus 2b.
Now, Layla, what do you notice is happening for each line of difference? What's disappearing?
Each like line will be each like letter will be eventually.
So I end up with an expression that I can solve with only one letter, which is easy to do. But I can't find A, B, C, and D because I've got 4 unknowns. The next line down, I've only got 3 unknowns. The next line down, I've got 2 unknowns. So finally, what I can say is that the third line of difference is going to be
6A
6a.
equals 2.
Uh-oh.
But then you don't find A.
We do. Right, so now what we have to do. So let me just make something clear. This table here works for, it's how it is for every cubic sequence. So if you can remember this, you don't need to write it down every time. Alright? But I can't. You know, I would have to just write it out quickly and do it. So it doesn't matter what the actual numbers of the sequence are, this will always be the same. This will never change, right? It's always A plus B plus C plus D, that so on, and we end up with down to 6a.
Oh, these numbers are always the same?
They're always the same. Now what we'll then, for a cubic, what we need to do now, so this is kind of something that you could write out in a set of notes, for instance, and every time you have to do a cubic, you just get this page out and put it down and go, right, now I can use this. I could do another one for a quadratic, for instance, right, let's get this out and use it. Right, I don't have to redo it every time. It doesn't change depending on the sequence. But what we're now saying is, right, I can use this table to work with these numbers. Alright? So these numbers now match with the stuff that I've got in algebra. Alright, does that make sense? So you've got all of these written on your paper, yeah? So I'm finding it difficult to keep swapping, and I think might confuse you. So let's do it a different way. So the first term, A plus B plus B, is equal to what?
2.
What? So it's 2. Got that? The second term is
7.
7. The third term is
18.
the fourth term is
38.
okay. So you can see that A plus B plus C plus D has to equal 2 because that's the first term. There's no way of solving that. Got 4. Yep, got.
If that's the case, then why is 3 highlighted the same as 38 on the top?
I think he meant to highlight 18, but he highlighted
Yeah.
38.
Oh, did I do it wrong?
Yeah. I was just gonna read it.
The third term. Oh yeah. I did it wrong. That should be the third term. Sorry. Should be 18. Alright. But well done for spotting. Now, what's the next line then? So now we're just dealing with the differences. So I did the differences between 2 and 7, and the difference between 2 and 7 is 5. So that means 7a plus 3b plus c has to equal 5. 19a plus 5b plus c is the difference between 7 and 18, which is, and then the difference between 18 and 38 is
Hey!
40. Okay,
That's the thing. Wait, no, it's supposed to be 20.
20. Okay. Now the third line of difference, well, the difference between 5 and 11 is actually 6. So 12a plus 2b has to equal 6. And 18a plus 2b has to equal 9. And finally, the third line of difference
3.
was 3. So of all of these things, look, the only line that I'm now able to solve anything is
A.
A. So using this piece of information, I can now tell you that A equals A half. Don't fall for it.
Would it not be 3 over 6?
Yeah, which is a half.
Which is a half.
Oh, sorry.
Yeah.
Oh, yeah.
Okay. So I know that A is a half. So if I were to go back up to here, right? I can see Sophia's getting so frustrated because every time she starts writing, I scroll away. She's like, you can see it. That I will.
Question that you probably mentioned earlier.
Let me just, yeah, I'll come back to you. So what I know is then the rule for this sequence is going to be in the form an cubed plus bn squared plus cn plus d. I now know that a is a half, so I can write it's a half n cubed.
That's what we found out.
So far. So far. All right?
But now we can work out the second layer. and the third
Exactly.
layer.
So now we've got information. So I now know that this A, all the A's are a half. So
Now it's easy.
12 times a half is 6, 18 times a half is 9. So I've got 6 plus 2B is 6. So I don't need this one. I only now need the first ones of each line.
Wait, B equals 0.
B equals 0.
So
So
would you put 0 into the equation, or do you just discard it?
yes, well, we don't need that, do we? But you might choose to write it to start with. But yeah, 0 times anything is just going to be 0. So eventually we won't write it at all. We don't need to. It depends what stage you're at with your understanding. So you don't need to put it. Yeah. So we've got B is 0.
Oh, that's a B.
Alright. So up here I've now got a half. So what 7 times a half is 3.5 plus 0 plus C equals 5. So C has to equal 1.5. Okay. Go up to the final one then. I've now got 1/2 plus 0 plus, I'm going to write 3 over 2, plus D has to equal 2. Therefore D has to equal, yeah,
Oh, I have a question.
go on.
How does? Oh, never mind. No.
You were asking 3 over 2,
How did
1.
you get 3
No,
over
no,
2?
I was
supposed to be 1.5.
It's the same thing, no?
There's a 1.5 and a half. No, that's 0.
Yeah.
D equals 0.
1.5 is 3 over 2. The reason why I did that, I could have done 0.5 plus 0 plus 1.5 plus D if you prefer. And 1.5 plus 0.5 is 2. So actually D again is 0. So, are you done, Sophia? Can I move? I don't
Yeah,
want
I'm
to. Yeah.
good.
Are you alright? Yeah. Okay. So I'm going to go back up to here. So I now know that B is 0. So I've got plus 0n squared plus 3 over 2n plus 0. Alright. So overall, that would just leave me with n cubed over 2, a half n cubed,
Plus 3 over 2.
plus 3n over 2.
And that's it.
That's it. Alternatively writing it, an alternate is to say n cubed plus 3n all over 2. But it doesn't matter which way you are, just showing you.
What about the n squared?
Got it? Because it's 0 times n squared is always going to be 0. Yeah?
You know how in like last time when we were talking about like the slope equation and how it was better to write it like a half than like the 8?
Yeah.
Are you allowed to like fully write it the alternative way this time? Like it's
You can always write however you like, as long as it's correct.
okay.
I think we were talking just what's more useful to use later on.
Okay.
See, if I now had to solve that for something, I'd probably rather have it like this, so I could multiply by 2. So, my question for you then, how are you feeling about that? So you found the rule for the sequence.
It was. Can we do another one?
I think we need a lot of time.
Well, yeah, so for the rest of this lesson you can have time to process it, but what I want to do first is just to say, right, because we've got that now, remember I said there was 2 types of questions that I could ask you. One would be, what is the 17th term? And also, is 6,327 in this sequence?
I can do the first one.
I could also say, give you a number that is definitely in the sequence and say which term is it. But that would be the same sort of idea, and I'd have to know the number, and I can't do it. So you can use a calculator. It's fine. So have a go at answering those 2 questions before we move on. Okay, so let's just go through it quickly. What is the 17th term? How do you find it? Go on.
You substitute it in for n.
Yeah. So n is 17, so we do 17 cubed plus 3 times 17, all divided by 2. And what did you get as the answer?
2,482.
Okay.
Oh, I could have done that.
You could have done that.
I did that a long way.
Oh. Did you actually keep going up to the 17th term? That is one way to do it. Right, what would be the next, to do this next one, is this a term in the sequence?
You just do
No.
n cubed. You just write out the formula and then equals 6,327, and then you work out.
Okay, go on then.
Oh. Then
Now
you
this
do-
one, we might find it's not something we can do at the moment.
Do n cubed plus 3n equals calculators.
Oh.
Yeah, that. And then you would do, I don't know.
Did you do
Don't you
cube
do 6,000 whatever that times 2?
What do you do?
Oh,
No.
Got your calculators?
No.
Oh my god.
Yes, you have. I see it next to you.
I'm not saying
Right,
no to
do you-
solve it, I'm saying-
Right, so this is a kind of problem at the moment that we don't necessarily have the maths to cope with. Okay? So, use your calculator. Alright? Do you remember how to solve a quadratic using the calculator? Using the poly...
Polynomial.
Yeah? So what you do...
Wait, is it real roots or complex roots?
So what you do... You want to choose the first one, which is the roots of the polynomial, and then when it asks you for the degree, you want to change it to a 3 this time, rather than a 2. There are lots of people without their calculator. You are going to not know how to do this if it comes up.
Is it real? Is it the first
It's real. There's no complex. And you put your values for A, B, C and D in that we've just calculated. So A being a half, B being 0, C being 3 over 2, D being 0.
Oh, we write 0?
Oh no, actually, sorry, no, I'm wrong. Forget that. What's A? 1. B is 3. No, B is still 0 because there's no n squared. C is 3. And D is minus 12,654.
But it says to equal 0.
That's because it's always equal. When we find roots, it's when it's equal 0. Yeah?
Oh,
So you have to set it up to equal 0. So just to remind you, we've got A is 1 because that's n cubed. We've got no n squared, so B is 0. C is 3. D is negative 12,000. Right.
I got 23.2599.
So it's wrong.
So you've got n is 23. Okay, so the question is that in this sequence?
No.
No.
It's not an integer.
Exactly.
Good job, Linda.
Wait, did you do 10 plus
Yes.
something? So, if it's a geometric sequence and it comes out as as non-integer, is that?
Same thing.
Yeah, you can
For it to be a term in the sequence, n has to be a whole number, doesn't it? Has to be first term, second term, third term, and so on. You can't, what does 23.2 terms? What does that mean? Doesn't mean anything.
I got 1.
So for this, let's do a quadratic.
Negative, you have to do a plus
Yes. Okay. Okay, we don't do anything hard enough. So this type of question is not the level. You wouldn't be asked necessarily to solve a cubic like this to find whether the number's in a sequence for a cubic. It's not within the scope of the course that you're doing. If you go on to HL and things, you'll have other algebraic methods to do it. All right. But practicing using your calculator now it shows you how you can do it. You can do it with quadratics as well, can't you? All right. So you've done the difference method. As I think you've been asking, can I go up, Sophia?
Yeah.
Okay. Right, so just to, I actually want to go down. As Sophia just mentioned again, if I want to actually do a quadratic, I only will end up going to the third line, and the third line will be something A, and so on. Okay. Also, do you notice how I only wrote out enough terms so that I end up with one of them at the bottom? If I'd have done a fifth term at the top, I'd have just ended up with 2 lots of 6a equals 3. So unnecessary extra. All right. So if I were to write this table out for a quadratic, how many terms would I need to write out?
3.
Just the 3. Okay. Just need to go as far as having, one of those. All right. Just to make it clear. So we now have 9 minutes left. So it's probably worth having a go at one of those other ones. Maybe try a different one from that exercise and see whether you can do it again.